Hey guys, today we're going to talk about properties of functions, okay? And I don't know if I've mentioned this before. I should have if I haven't, so I apologize. I put little numbers right here, and if you see these numbers, it's where what I'm speaking about can be found in your OpenStax books, okay? So if you are like, where is she finding this odd and even functions business? It would be in chapter 3, section 5, okay? So that's what that is, okay? Let's continue on. So right now we're going to talk about odd and even functions. So a function whose graph is symmetric with respect to the y-axis is called an even function. So if you, it's kind of cool. I usually in class I demonstrate this, but it's kind of hard online, so I'm just going to write it. So if you, well, or maybe I'll just say it. How about I'll say it because it's hard to write. If you fold this graph in half on the y-axis, you will see that it is the exact same, right? So it's a mirror image of itself. So that is an even function. Now, an odd function is a graph that is symmetric with respect to the origin. And that is, I'm sure you guys remember me saying this from before, but that is this little crosshairs right here, right? That's called the origin. Undo. So now, along with the folding of the paper, the same idea. If you will fold it in half on the x-axis, and then once you've done that, fold it again in half on the y-axis, then it's an exact mirror of itself. So you can just kind of see fold it and then fold it again. It would be the same, okay? And that is an odd function. So let's see. It's symmetric with respect to the origin. So that's an odd function, okay? It's good to know that. And I don't know if ever I'll have reason to write it, but with respect to is W with respect to. So if, like I've already said, I'm lazy. So instead of writing with respect to, I write that. So just if you see that, no, that's what that means, okay? I don't want you to be like, what the heck is she writing? That's what that means. So, okay, let's go on. Just learning all kinds of math terms in here, aren't you guys? Okay, so this is, instead of like, we don't always fold papers as mathematicians, this is how you prove mathematically or algebraically how if something is odd or even, okay? So let's go. So if it's an even function, you always, let me back up, you always plug a negative x in. So plug negative x in for, this is my in for symbol, in for x, okay? So here, we see that we put negative x here in for this x. So if you do that with an even function, the right side of the equation of an even function does not change, all right? This is an even function if x is replaced with f of x. Now, with an odd function, every term on the right side of the equation of an odd function changes when we do that, okay? So every term changes. Even, nothing changes. Odd, everything changes. Now, let's pick a different color. Now, neither even or odd, we plug the negative x in for our x, and some things change, right? The right side of the equation changes if f of x, or if x is replaced with negative x, but not every term changes, okay? So some will change, but not all will change, okay? So that's what we have to look for when we're looking to see if it's even, odd, or neither. Okay, let's do some problems here. Show my black to start with. Okay, no, I don't want black. Let's do pink first. Okay, so on the first one, remember that we're going to plug negative x in, right? Okay, so over here we're going to have f of negative x. Then when we plug anything in for x, we always put it in parentheses. Times our negative x. Now, if we cube a negative, it still stays negative, correct? So that's going to be a negative x cubed. And a negative times a negative is a positive. Okay, so if we look here, both terms changed, right? So everything changed, right? That's what this says. Everything changed. So, orange. So here, both terms change. Okay. So since both changed, we know f of negative x equaled negative f of x, right? So it was just like we multiplied that guy by a negative. So that implies, remember this means implies, that it's an odd function. Now I'm going to tell you just a little tip, little way to check yourself. This exponent was odd, and this one is raised to a little implied 1, right? We know if there's not one, it's not a power written that is always implied. So 3 is odd, 1 is odd. So these had odd exponents, so it's an odd function. It's a great way to check yourself. All right, let's do another one. Let's do blue. Okay, so let's do this one. This time we're going to do the same thing, right? We're going to plug in our negative x. So this is going to equal, again, we're going to put it in parentheses. Oh, 4, not squared. Minus 2 negative x squared. Okay, so the way I always thought about it when I was in college algebra, if you have an even exponent and you have an odd term that you're raising to that exponent, your even exponent eats that negative, right? Because if you have a negative times a negative times a negative times a negative, well, these two become a positive, and these two become a positive. Well, positive times positive is positive. So if you have an even power and a negative that is being raised to that even, it always eats that negative. Get rid of these marks. We don't need all those over there. So with saying that, negative x times itself 4 times is going to give us a positive x to the 4th. And then this is going to be a positive, correct? Same thing. Even exponent eats that negative. So it's going to be minus 2, ooh, ugly, x squared. Okay, so this is exactly the same as this, right? So neither of those changed. No change. Man. Sorry, guys. So no change. And since there's no change there, we know, come on, that's G, isn't it? So G. So G of negative x equals G of x. All right, nothing changed. Okay, so that implies even. Now the last one. I don't know. Black. It's black's good. So H of negative x is going to equal negative x squared plus 2 times negative x plus 1. You can see 1's not going to change, right? We didn't multiply by anything. This one is still x squared because the 2 even power ate that. So x squared. Now this is minus 2x plus 1. Now some changed, right? This guy no change. This guy changed and this guy no change. So some changed. Ooh. I'm just going to write. Maybe I'm not. My gosh. Okay, so some changed. So that means that it's going to be neither, right? So that implies neither. Okay, neither. Now this one, like I said before, this one has a 4 and a 2, so it has even exponents, so it's an even function. And this one has a 2. Where's my little orange color? It has a 2 and a 1, right? So it's an even and an odd, so that way you know it's neither. So there's just a handy tip for you to be able just to look at it. Sorry. Need a drink. Be able to look at it and tell which one they're going to be, okay? All right, I'm going to stop it there because that seems like it's long enough, and we'll do another one in a sec. All right, have a good day.